Hello everyone. So a very low turnout for the first class, I feel. It's probably due to the lecture coming on a Tuesday, which is a working day, but no worries. Uh, yeah, so let's start with whoever is here. So first of all, I welcome you all to this doubt clearing lecture for the course Smart Grids Basics to Advanced Technology, being taken by Professor NP Padhy and Professor Premlata Jena. I am Swastik Sharma. I am a PMRF scholar at IIT Kanpur. And yeah, so also greetings of the day to everyone who will watch this on YouTube. So eventually this will get uploaded on YouTube. So before I begin, so I would like to ask, so there are only two people. So I wanted to know whether or not you're BTech students or are you from industry? So yeah,
BTech third year.
BTech third year from which college?
Alja Institute of Technology, West Bengal.
Oh, from West Bengal. Nice. And the rest of the audience, where are you from?
Sir, my name is Muhammad Naki Akhtar. I
Yeah.
am lecturer in Government Polytechnic Sahibganj, Jharkhand.
Okay.
I am doing this for a PhD purpose.
Oh, okay, okay, okay. And the rest of you, Selva. Yeah, come on. It's only five people, right? So let's introduce ourselves before we begin. So if someone wants to make an introduction, Ranjit Pandey is there. Oh, Selva, yes, go continue.
Sir, good evening, sir. I am Arul Selvanayaki, lecturer of EEE department from Tamil Nadu,
Oh,
working at Ranganayaki Varadaraj College of Engineering.
oh, nice, nice. And
Okay.
Mr. Ranjit Pandey. Okay, so I feel he's not willing to give his introduction. So, anyway, so today we are going to be discussing week one. Whatever was covered for the course during week one. So we're still in week one. I mean, week two lectures are now ready, but let's discuss week one first. So that
Hello.
yeah, good. Yes,
Hello.
yes, yes, Ranjit,
My
good.
my name is Ranjit Pandey. I am pursuing my MBA in Power Management from
Oh,
NPTEL Farid. Power
oh,
Management.
oh, nice, nice. NPTI.
Yes, NPTEL Faridabad.
Oh, nice, nice, very good. And we have few more joinees. So if someone wants to introduce themselves, Om Shiva. Okay, so whoever wants to feel if they are ready to give an introduction, they can just unmute themselves. I mean, this is a class where I would want to have active participation from all of you. I mean, it's a doubt clearing class, but still there should be an active participation from everyone. So if I'm comfortable, so if all of you are comfortable, so I would want to know if you are comfortable in Hindi or English. So because I feel there are people here from South, so they will be more comfortable in English. So we'll keep the medium of instructions in English only, so that it's comfortable for everyone, right? And yeah, so we are now. So we'll start discussing. I'm junior to all. Yeah, you're junior to everyone here. No worries, but you'll be giving the same assignments, the same exams, so you have a lot to prove, right? Okay, so let's begin. Let me share my screen. Okay, it's visible. Okay, so is this course for me? See, the Smart Grids course. So NPTEL is a very wonderful platform for people from all. What can I say? From everywhere, from any designation, they can come and participate, right? NPTEL is for faculty development programs, student development programs. Then you have courses which are of interest to people who are pursuing MBA, for example, from National Power Training Institute. So it's not like it's the course is for you or not. The course is very basic. So if you know basic electrical engineering, you will be comfortable with the course, rest assured. So you can just take a bet on me. that this course you won't feel as if it's going above your head if you are comfortable with basic electrical engineering, because that's not something that I'm going to teach. That is something I hope that all of you are comfortable, and I'll just take this as a prerequisite for this course, because it's already given in the course, what is the introduction. Yeah, you're from E, yeah, so you know basic electrical engineering, right? So it's a very basic course. Okay, so don't worry, you'll be able to get good marks, get good grades from this. Yeah, no worries. Okay, so first of all, so what is this course about? The course is about smart grids, right? So we'll start from the very basics, very fundamentals of what exactly a grid is, what makes smart grid different than the conventional grid that we have, and what is the basis on which that we are going to, tell people, okay, let's go to smarter grids, because now conventional grids are not ready to support uh, further advancements in the technology, further technological advancements, right? So how that happens is what is going to be covered in this course. So people who are joining late, so we have already begun. So I mean, I have not started yet. I'm just giving a brief introduction. So I hope that all of you can follow. But if not, just unmute yourself, and I'll be happy to give you a brief of what we've covered so far. Right. So so that's what is happening in this course, right? We are going to talk about why smart grids are necessary and why they are a necessity because of the increasing technological advancements at present in the literature, right? So the conventional electrical grid, it was all generation. It was of three verticals only, right? There was generation, then there's transmission, and then there's distribution, right? So generations have generators which generate electricity. Transmission systems have transmission lines, or apparatus to improve the transmission status of these electrical energy, and they transport this electrical energy from generating stations to distribution stations, right? So that these stations, which are further connected to our homes, to loads, to demand, they are able to cater that, right? So this is what the basic block of the sorry basic block diagram of a generating conventional electrical grid looks like. So we have a generating station where, let's say, we have different generators connected. So and these are then connected to transmission lines which operate on these voltage levels. So we have a very high voltage level of 800 by 765, 400 kV, 220 kV, and 132 kV. So these are the standards, and we have HVDC lines as well of 500 kV. So after this, so obviously, so the generating stations don't develop electricity or electrical energy at such a high voltage level. They are approximately up to 11 kV. So what they have is they have step up transformers which step up this voltage to a voltage that can be used to transmit electricity. Why is that? I will cover once you just get a feel of it. We'll discuss why this step up is required. After that, since this step up is of a very high level, we can't use this directly at our homes, right? We can't use 132 kV, 220 kV. It's not something that our devices are ready to use it. We use 5 volts of what you can say, the charger of your phones. They connect to 220 volt, but they decrease it further down to 5 volts to charge your phones, right? So you can't use an apparatus to convert 132 kilovolt directly to 5 volt for your phones to get charged on. So these are then converted to step down using a step down transformer to a level like 33 kV, 11 kV, or 6 kV, or 400 volts. So 400 volts are generally used, are called secondary customers, because these are the customers that come after the primary customers, because they are generally given a very high voltage level of 11 kilovolt. Sub transmission customer, why do we call them sub transmission, is because this 33 kV is still very high, and there are industries which may want to use such high voltage levels, right? And these primary customers are also catering to industries only, but this 400 volts is mostly used by residential, or just a second. Yeah, so residential or businesses, let's say, right? So now why why is the need of doing all of this? There was this war of currents that happened during 1880s to 1890, right? Between Tesla, excuse my handwriting, if you don't understand, just let me know, right? Tesla versus Edison. So they both fought, they fought for so just a second. Yeah. So they fought for Tesla fought on behalf of AC, and Edison fought on behalf of DC. And they both wanted, because at that time both were separate, they were both having separate companies which catered to different set of customers. So what they wanted to do was they wanted to set a standard for the whole of the United States on which the electrical infrastructure would be built, right? So they both fought, not like fought with hands or muscles. They didn't use their they didn't fight physically, but yeah, it was like a cold war between both of them, because they wanted each of their innovation to be used mostly, right? So Edison wanted DC and Tesla wanted AC, right? How funny is that? Now you will see in your newspaper sometime that government is considering HVDC transmission things. We've come a long way. But yeah, 1880s to 1890s was the time when it was decided whether or not we'll go with AC or DC. And who won? Can anyone tell me who won between both of them?
Tesla.
Tesla won. So Tesla, it didn't. So you have to. There was this movie. I don't know. It's a biography on Tesla. You should see it. I mean, Tesla, even though he was revered to be a very very great scientist, but his end was very very unfortunate. You should see. I mean, so yeah, AC won because of the fact that why do you think AC won? Why not DC? What was the logic?
Because AC is alternating and it supply a high voltage also, and DC does not. DC
DC.
is direct.
Okay, at that time, yes. At that time, there were advancements in ACs that could uh, support this transmission of high amounts of power using AC equipment, but not with DC. So right now, why is DC now being favored? Is because we have made advancements in power electronics. So power electronics, if you all know,
Rectifier will not develop at that time, I think.
yeah,
To
they were not available at that time. They were just DC was being,
to convert AC to DC.
yeah. So power
Yeah.
electronics, now the advancements in power electronics support DC because they are switches, right? So you can control switches uh, to develop a rectifier to convert AC to DC. So now DC is being favored because we now know that DC has certain advantages over AC, which AC cannot cover. So what are these advantages? So AC suffers from power losses, and this power losses is due to the fact that there are both I square R loss plus losses due to inductances and capacitances, right? So I'll call it reactance. So both of them add to it, and one more thing adds to it is skin effect. So what is skin effect? Can anyone tell me briefly? If someone can tell me, I'll talk to you about what is skin effect. But if someone wants to, unmute themselves and tell what is skin effect.
वो जो ब्लू कलर का इफेक्ट आता है तार पे.
No, that is corona. Skin effect is yeah. Go ahead.
अंडर द स्किन इफेक्ट मत क्या होता है ना, एक वायर के अंदर जो उसके पेरिफेरल पे बस वो इलेक्ट्रिसिटी फ्लो होता है, अंदर में नहीं होता है.
Yes. So what happens in skin effect is that the conductor which carries current does not uniformly distributed across its whole cross section, right? So that is not distributed across the cross section. Like there should be current at each point of the cross section, but that does not happen. It usually flows at the outer area of the cross section. Why is that? Why does this happen? So does anyone know the answer? Why does this happen? Okay. So
Because
yeah, go
high
ahead.
voltage wire is twisted.
No, not because of that. So this happens because when AC flows, when it flows, it creates magnetic field with it, right? So these are alternating currents, right? They produce alternating, they not alternating, but they produce magnetic field. Changing magnetic field is what you should call, right? So this changing magnetic field induces eddy currents. So these eddy currents, I'll just denote it like this. These eddy currents are strongest at the inside of the cross section because of the fact of Lenz's law. So when a current flows, let's say when current flows in the conductor, I'll draw it beneath. So let's say this is the current in conductor, right? And when current flows, what it does is it creates a magnetic field surrounding it. Now this magnetic field creates eddy currents, which, right, these eddy currents. So what these eddy currents do, they oppose the very nature of the current that produces it, right? So due to the Lenz law, what does Lenz law states? It states that the effect of induced current is to oppose the current which produced it, right? So this is not an axiom. I mean, I'm not putting it a law here like this is exactly what it states. I mean, I'm not going word to word, but this is the crux of it. So we denote it by E equals to minus N d phi by dt, where d phi by dt denotes the magnetic flux linkages, right? So what happens is these are most prevalent at the inside of the cross section, and when these are formed, they force the current at the outside of the periphery of the surface, right? At the periphery of the surface. You can imagine it like this. Like for example, um, let's say, okay, we'll come to that. I mean, we'll come to an example. So this is what happens. So they force the current to flow at the surface level, right? So what happens is the effective cross section area, it becomes smaller. Now, when it becomes smaller, R, we know effective resistance. When A becomes smaller, R increases. Now, when R increases, what happens? The line losses will increase. So, skin effect adds to the I square R losses, which are already there in AC transmission system, right? Now, with increase in frequency, so let's say, for example, if I increase my frequency, so what will happen? If frequency increases, what will happen? Can anyone tell me? So this is covered in the lecture, I feel. So if frequency increases, what will happen? So think of it in this way. You are carrying a pipe, right? And that pipe is connected to a water source. And let's say the water is coming out of the pipe at a very low pressure. So what happens is it is concentrated at a small circle, right? So the pipe which carries water, the water rushes out from a small circle only. It does not flow from the full, what you say, from the surface of the pipe where the water comes out. It just flows from the very small cross section of the pipe. वो छोटे से क्रॉस सेक्शन से पानी निकलता है जब प्रेशर कम होगा. पर अब तुम प्रेशर बढ़ा दो, इंक्रीज द प्रेशर, व्हाट विल हैपन? So the water comes out covering the whole cross section of the pipe, right? It comes out very fast. So that is what happens with frequency as well. When you increase the frequency of alternating current, the skin effect, it also increases. So this is one drawback of your AC transmission systems, right? This is not at all prevalent in DC. Why? Can anyone tell me why DC does not have skin effect?
Frequency is zero, sir.
Yeah, frequency is zero. It's just a steady state current, right? So there's no frequency, but yeah, there are still I square or losses, but they don't become very prominent because of skin effect. And there's one more effect called proximity effect. Can anyone tell me what is proximity effect? Okay, so what do you understand by proximity? Proximity means in close contact, right? So let's say there are two wires. I'll just make a demarcation so that you know that So let's say there are two conductors, right? So they are in close contact. I mean, not contact. They are just kept very close to each other. Their proximal distance is very small. Now, let's say when you have when you have AC current flowing between both of them, and AC is pulsating in nature, right? It increases, then decreases. Yeah, two conductor carrying current. Yeah, proximity effect. But you have to explain what happens due to that two conductors carrying current. You want to close together, okay? What happens?
It will decrease. It will oppose the flow of the current.
It
Both
will
will oppose
oppose the flow of
flow
the
of the
current.
current
It will oppose the
to
flow of the
each
current
other
in each other. Yeah, right. Why? Why is that?
because of Lenz's law.
Because of Lenz's law. But how does Lenz's law come into picture? Again, think of it because of eddy currents.
Proximity effect.
Yeah, yeah. Who is saying?
Yes, my name is Ganesh, sir.
Yeah.
Proximity effect is to the unequal distribution of current. So, because of current in inner surface of field area.
Okay. So, Mr. Ganeshan. So, I'm sorry, but your mic is very, it's not giving me proper. So I can't hear you properly. Um, Right. So I
Okay,
hope,
sir.
yeah, I hope you would, you can always talk in chat box, but yeah, your voice is it's very inaudible. So what happens is, so there are the pulsating current, which is the AC current. It's pulsating in nature. It induces eddy currents, right, in the nearby conductor. So these eddy currents counteract each other. The change, because why would they counteract? Because of Lenz's law. So they want to oppose the change that created them, right? So they want to oppose each other's magnetic field which created them. Now what happens is, due to the fact that due to the fact that these eddy currents are now produced, the source of the magnetic field, that is the source of the magnetic field which produced them, are very closer to each other at the sides of each other's body, right? Here the magnetic field which will be more prominent because they are very close to each other. Now the eddy currents, what it does is it opposes them, and it forces, excuse me. So what it does is it opposes the very nature that created them. Now what happens in the main current where the current was flowing, in the main current where the current was flowing, it opposes that current. So it gets pushed in the opposite direction. Now when this amount of push happens, what happens is the effective resistance that it was witnessing while flowing through the conductor increases, because it's now experiencing another constriction due to the fact that there is a proximity effect due to another current carrying conductor placed nearby, right? So it faces now more resistance, so more constriction, lesser area to flow by. So due to this, it experiences more resistance, and the flow is less, which leads to higher I square R losses. Now, DC transmission systems, they are very ideal for very long distance. Why is that? Because when the distance increases, the inductance, the capacitance, and these I square R losses also increases, right? So when these losses increase, due to the very fact that DC does not have any reactances in it, the flow, the transmission losses are very less, and that's why they're favorable. This long distance, if you want to quantify, it will be greater than 500 kilometers. Only for the lines which are greater than 500 kilometer, you will feel that DC transmission is more ideal than your AC transmission systems, right? Now, renewables that are located very far from load centers can be connected through DC lines for efficient operation, right? Now, renewables, they are already very intermittent, they are already very variable, right? So you don't want it to experience more. Yeah, someone wants to talk? Okay. So you don't want to you don't want them to be, kind of like a lossy, because the renewables are generally at a very at remote locations, and the load centers are at a different locations. And you can connect these using DC high voltage DC transmission line. Also, DC does not require synchronous connection. So when you want to connect an AC generating station to a grid, you have to synchronize the voltage, frequency, and phasor. That's very important. You have to synchronize all of this so that there is only one synchronous frequency. But HVDC does not have this. You can just have a converter station and you can easily interconnect any line to it. Next, EMI is less in DC. So I'll say less. I won't say there is no EMI, but yeah, there is lesser EMI in DC. Why is that? Is because in AC, you know, there is alternating current and it produces alternating magnetic currents and magnetic fields. And what happens is there is a chance of getting EMI, especially at high frequencies. But this does not happen in DC. This only happens at places where converters are located. Why is that? Is because converters operate at a very high frequency. Wherever there is higher frequencies, EMI will be there. Now, you know, right, what is EMI? What exactly is EMI? So EMIs are interferences or disturbances that are caused in your voltage signals or in your voltage signals or in your uh, mm, uh, let's say voltage signals due to the fact that they are traveling at a very high frequencies, right? So when that happens, they experience distortion. So that is caused due to the electromagnetic interference. That is not prevalent in DC, only at the substations where high frequency power electronic switches are located. Right. So coming to India. So in India, so we have a unified grid, right? So we have a unified grid. What does unified grid is? It means we have only single frequency across all of our main regional grids, right? So this unified grid is being operated by Grid India, which is also called the Power System Operation, which was called the Power System Operation Corporation. But Grid India is mainly responsible for operating and ensuring power distribution across India, right? They have to ensure that supply and
सर
demand
प्लीज
is
यूज
balanced.
रेड पे
Red pen, okay, okay. Oh yeah, so it's visible to me, so it's my bad. Okay, so what is this? It's responsible for operations and distribution is also operations of power distribution. So it is responsible to manage supply and demand balance. It has to maintain supply and demand balance, because if supply and demand balance does not happen, the frequency is inadvertently affected. So the frequency, it's very closely linked to how your supply and demand goes. So frequency increases if supply is greater than demand, and frequency decreases if supply is less than demand, right? So you need to make sure that your supply and demands are completely balanced so that your frequency, it does not go beyond a certain operating range. And this operating range, according to Indian Electricity Grid Code IEGC 2023, I hope it's 2023. Yeah, it's 49.9 to 50.05. Right. So within this operating range, it has to manage. It has connections of AGCs to govern. Will come. Just take this as face value. We will discuss what are AGCs and other stuff in the coming lectures. But they have governors. They have controls. They have control mechanisms to increase supply if demand increases and decrease supply if demand increases. No, sorry, increase supply if demand increases and decrease supply if demand decreases. Right. So Grid India, it manages in itself 5 regional grids. It's called Eastern Region Load Dispatch Center. Then we have Western Region Load Dispatch Centers. Then we have North Region Load Dispatch Centers and South Region Load Dispatch Center, and one more, NERLDC. Right? So these, the Grid India's role is to coordinate, because these are subsidiaries under it only, when they come under the same umbrella. So their responsibility is to coordinate with each other for interconnected intergrid operations, and in itself it has to contact with the state load dispatch centers for intra-grid connections, right? So each region load dispatch centers has state load dispatch centers which are unique to each state. So like for example, UP will have an SLDC, MP, Gujarat, so each of them has SLDCs as well. Now it's not just this. The Grid India's responsibility is not only this, but it has one more responsibility, right? So right now there is a proposal of India Sri Lanka HVDC grid interconnection, where they are currently proposing a link to unify the grids of India and Sri Lanka by using underwater cables, right? So this project is still going on, and it's a very what you can say, it's a very nice project for national relations. But we not only have this, we have more. We are in contact with other countries as well. So like for example, we have interconnection with Nepal, we have with Bhutan. So what we do is we import electricity from Bhutan sometimes, and we supply electricity to Bangladesh, Myanmar, Nepal. Now there is one more project which is currently, I don't know if it has taken shape or not, but there was this proposal to link Myanmar and Thailand. So Myanmar and Thailand are both very close to each other. So they wanted to link Myanmar and Thailand so that there is a conglomerate of these South Asian countries who can act as a power pool, right? So that is currently also going on. So there is not only this. So Great India is not only responsible for operations of India, but also responsible for this these major projects as well. So one main thing that you will see is that India is pushing for, so I'll come to this slide later. I wanted to discuss something else as well. So India is pushing for, I'll just keep here. This slide was meant to be at the last. Okay, I'll just do it. So so why is that? Why is we keen on pushing for, generating more electricity? We want to generate more electricity because electricity is directly linked to economy, right? So if you want your economy to boom, if you want your industries to be facilitated, your EVs that are now coming to the picture, how will they get charged if you don't have enough electricity generation, right? So as you can see, this map I have recently taken, it's only updated till 2023, but yeah, I mean, the review was done in 2024, but that data takes only till 2023. So you can see that China, for example, it has taken such a steep growth. It's constantly evolving. It has now reached 10,000 terawatt hour electricity generation. But we as Indian, as India, we have only, we are also progressing, but our, sorry,
One reason is carbon footprint,
yeah.
carbon emission.
So just give me a second. Yeah. So one reason is, so we want to increase it very economically. We want to address climate change as well. We want to address our carbon footprint as well, right? So it's not like we keep on adding, thermal power plants. So United States, it will come with, I have one more slide. United States has a lot of power that comes only for coal-based generating power plants, right? So see, these first world countries, they lecture us, that we are not meeting the standards of climate change, right? But they themselves use only, so when they were a developing nations, so they use only this coal-based power plants to generate electricity. Why is that? Because that is already a technology that has matured, and you can easily connect and not easily, but you can easily support your generation with thermal based coal based thermal power plant. But for India now, due to the fact that we have to reduce carbon footprint, we have to meet our climate goals, we have stuff to cover, so we are taking very very small steps or very small strides in this direction, right? So we have just approached 2000 terawatts of terawatt hours of for electricity generation.
But we have shifted to renewable energy sources.
Yes, but we are also building capacity in coal-based thermal power plants, but yeah, not the kind, not like very. So you may see that UP has certain. Recently, there is a new project going on in UP or MP where they are constructing a new coal-based power plant. So it's not like we have completely swapped coal with renewable, but we are just making sure that coal does not offset renewable at a very large pace, right? So now you see that the primary energy consumption, right? What is primary energy consumption? The consumption that happens at the feeder level, which is the small low voltage distribution level, right? So so this energy, it's
I think from now 2025, it is mandatory. RPO, RGO, and RCO is
yeah,
mandatory.
I'll talk. So
For,
that are more for distribution companies, RPOs and these, but I'll come to that. But just stay with me for a while. I'm just building a
Okay,
picture
okay,
for
okay.
you. Yeah. So I have these night slides, so I'll cover everything for you. So see, China needs energy. So China's energy consumption stands at 50,000 terawatt hours, right? Closer to 50,000 terawatt hour. While for India, it's above 10,000 terawatts hour, right? So for China, they are still a long way, to reach that amount of energy. But for India, it's not going to be easy as well, because the jump from this to this is huge, and this needs to take effect certainly by 2047 if we want to become a developed nation. You can see United States, their primary energy consumption has stagnated to the point that they don't require building much more electricity generation. That's why they are not building more power plants as well. You see, they are not building at all. But now see, what is the share of this primary energy consumption that comes from renewable sources? So Canada has the highest amount of power that comes from renewable resources, which is being used for consumption. So there is a difference between electricity generation, right? You can have power plants, but they may not be used for energy consumption. They may be used for supporting load growth and stuff like that. Direct energy. So the parameter that governs how and why you should increase your reliance on renewable resources is the parameter of your primary energy consumption. So see, in Canada, it's 30%, right? 30% is huge, and they're still managing. Same goes with Germany, United Kingdom, France, and even China has 15%. But for United States, it stands at 10%. So they only use 10% of their energy from renewables, right? So they have majority of power plants, thermal based power plants, which are being used right now as we speak to support the primary energy consumption in their areas. But for India, we are also at the same level. So right, you now see we need to go from 2000 terawatts to above 4000 terawatts, but we also need to increase our renewable energy reliance. So for this, India has set a very mammoth task, which is 500 gigawatts of renewable energy by 2030, right? Is this correct? Can anyone tell me if this is correct? Okay. I mean, I feel this is correct. I mean, I've taken it from somewhere, but yeah, this is correct. So see, I took this from MNRE's website. So you see that what is the thermal and renewable breakup for us. So we don't keep nuclear in renewable because of obvious reasons. But yeah, nuclear is also a subset of renewable energy resource only. But yeah, even hydro. So we don't keep all of the hydro here. We only keep small hydro power plants, which are less than or equal to 25 megawatt. Why is that? Why don't we include all of the hydropower plants? Hydroelectric power plants are renewable, right? It's the river flows, it continuously flows. We can generate as much amount of electricity we want. Why do we feel the need to classify it into small hydropower and large hydropower only for it to be not called renewable? Does anyone have any idea why do we differentiate small hydro? Why not hydro power plants equivocally?
Because it generates low electricity than
No,
hydropower plant.
no. You know, when 2020 happened and Prime Minister Narendra Modi wanted us to switch off lights at 8 p.m. for 5 minutes and, uh, light a candle for doctors. So, at that time, hydroelectric power plants were the ones who supported that ramp, that largest ramp our grid has ever experienced. So, all of these news anchors and news people, they were like, our grid will fail, but it didn't fail. Grid India managed everything perfectly. Why? Because of hydropower plants. Hydropower plants can ramp up very quickly. Thermal power plants can't ramp up. What do I mean by ramp up? It's increase its generation given a certain amount of time, right? Hydropower plants can do it very quickly, but thermal power plants can't do that. So it's not like hydroelectric power plants can't generate electricity or can't generate much electricity. So they can, but that's not the correct reason. So the correct reason is these large hydropower plants, they are basically run off the river. So what you do is you change the course of the river to create a dam. Now, when you're changing the course of the river, you are causing I don't know how many things, but I'll just list it out for you. So A, you are causing harm to the natural habitat of the fisheries over there. B, people who relied on that water resource will not be able to use that water resource now. 3, there is a large amount of this carbon dioxide emission or carbon emissions due to the fact that the river has not changed its course, right? So the earlier where the river used to flow, there used to be water beds and stuff like that. Now that leads to carbon emissions. So India is, I feel, is one country which uses this definition that hydros which are less than 25 megawatt should only be used to calculate our renewable energy growth, right? So in this we have developed all of our regions to different sects, and we have calculated how much of the energy generation comes from which kind of fuel. So you can see Western is the largest producer of electricity, both thermal and renewable, right? So it's the largest, and while and you can see, right, our goal. So we wanted how much renewable? 500 gigawatts by 2030. It's 2025 now. So we are at 209.44 gigawatts. Sorry, I'm sorry, right? So 300 megawatts, approximately 300 megawatts we have to add, and we can add, and what can support this is smart grids only. Only a smarter.
Presently, we have 89 gigawatt or 91 gigawatt in
Mhm.
renewable.
Recently,
Presently, we have, I think, 89 gigawatt, no?
no, 89.
Generation of renewable energy.
No, I took this, it's from renewable energy. How can you say that it's, I mean, it's a published study which says 209 gigawatt.
I think only we have solar generation is 89. I
Solar
think.
generation is also not 89. I feel it's around 120, 140, or
Okay, so
217 gigawatt by 2050, 25.
I mean, whatever it is.
207.
Yeah. So it's 2024. So this data is up until 31 December 2024. Yeah. So we are going to reach that capacity, but it's going to take a very large amount of time. That's for sure. So what can support this is a smarter grid. Now let's come to the need. So I talked to you about, right? So we have such ambitious targets, and from the Indian context, that is where we feel the need of a smart grid. So for me, when I define the smart grid, what do I say? So why smart grid? What is smart grid? So I generally like to use this definition that it's a conventional grid only, but now it has got a brain of its own. You know, it can think, it can mimic, it can provide data, everything to you. So now that is what a smart grid is. It's a conventional grid, but now with a brain in itself, right? So So I think there is a breakup as well if you want to look. So solar power is 98, that's what it's saying. And the total capacity right now, excluding large hydro, so this includes large hydro as well, it's 162 gigawatts only. So close, but not there yet. So what is the need for smart grid, right? So now think from the perspective of Grid India. It's sitting at Delhi, right? And it needs to control the grid from all of these regions. So you have this wide geographical spread, right? You have renewable generating stations at one place, you have load centers at different place, you have such a huge geography or in this, right? So just a second, I think I should do full screen. It's visible, right, to you? This silicon availability, smart grid and silicon availability. What is silicon availability? Okay, why?
For
Yeah.
for photovoltaic
Oh, okay.
energy.
Oh, yeah. I mean, yes, but there's more groundbreaking research happening right now. So, it's not just silicon. There is one more metal that they are currently testing on. So, hopefully, yeah. But the screen is visible to you, right? Whatever is there. This is my iPad screen. If someone can just say yes, it's coming very small
Yes.
for me. Yeah. Okay. Okay. So, yeah. I mean, silicon availability. Yeah, sure. But we I mean, uh, how can I say? So it's not just solar power, right? You have wind power, you have other stuff as well. But yeah, solar power uh, is much more. It's being integrated, or it's being uh, employed at a much more faster pace. It's because of the fact that India is a solar rich country. We get ample amount of sunshine. We'll discuss later. But yeah, I'll first discuss what is the
We
need
are
for.
moving to green hydrogen.
Yeah, we are moving to green hydrogen as well, but it will take a lot of time. I mean, I personally support hydrogen-based vehicles, green hydrogen-based vehicles instead of electric vehicles, because you don't have the infrastructure to support the large amount of charging requirements EVs will ask you for, right? So, yeah, I mean, green hydrogen is the future, but there's still, people are still doing research. So the technology has not matured yet. That's what I would say. So 7 to 8 years from now, how many of you would have thought, right? We will be not 7 to 5, it's 10 to 15 years from now. How many of you would have thought, like, okay, we will be focusing on renewable rich energy? Nobody was even thinking of it by then. They just started doing it. Why? Because our electricity demand increased very exponentially. That's what is happening. So we'll talk about that as well. But yeah, the need for smart grid is because we have a wide geographical spread. So bear with me, it's 2 hours lecture, but we'll have this discussion, but I still have to cover the material, right? So we have number of interconnections, so there are a large number of feeders, distribution, transmission. I don't have the perfect number in the back of my mind, but our 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 number of interconnections are very huge. So to manage all of that, we need smart grids. We can't sit at each bus and tell you about the location and what is happening at that bus, right? Rapid growth in demand of electricity. So what is happening right now? We are so the middle class has now become. It's still middle class, but we are having more money in our hands, right? 15 years ago, we talking about me, I come from a very middle class family, so we had only one AC, right? And now we have three. So it's increasing, right? Our spending power is increasing. So because our spending power is increasing, our standard of living is increasing. Our standard of living increases the
Still, I
electricity
have
use.
no.
You don't. I mean, where do you live? Oh, West
I am
Bengal.
from Bihar.
Oh, Bihar. I mean,
Bihar, not.
okay, so I mean, you'll get there eventually, but yeah, we don't have ACs at my hostel. At IIT Kanpur, we don't have ACs, so you must know what happens. It's UP, right? So it's the same for us as well. We are still living without ACs, but yes, the standard of living is increasing day by day. I mean, it is increasing, and that is something that we have to acknowledge. So It's not like the same amount of energy we used 15 years before, we are using the same amount. Our energy needs have increased. Also, the power system components, yeah, right. So these electrical infrastructure, this grid, these transmission systems, they were laid a very long time back, right? So now they are at their operational limits. So if they are at their operational limits, we have to increase the investment. And there is a very interesting research area which deals with the cost deferral of this investment. So you want to defer this cost as much as possible because this cost is huge. It's very high. And that is an area where smart grids is playing a role. Also, you have high penetration of renewables. So your renewables is increasing, right? So it's causing variability. You have, let's say, solar, right? And a cloud cover comes and your solar stops generating energy. So that intermittency and that variability is causing, problems for the infrastructure right now. Also, our electricity market. So we as consumers of electricity have now started to think of a good way of price discovery, and that is a competitive market. So what happens in a market? Your suppliers plus your what you can say, your distribution providers. So, or I should say retailers, it's much better term. So your retailers, they come, they say, okay, I want to consume this much amount of electricity at this rate. Suppliers say, I want to consume this much electricity at this rate. And there is this price discovery, right? So what this price, this is MCV and this is MCP. This is market clearing price, this is market clearing volume. So this price leads to a competition between suppliers, right? So they want to be able to, these suppliers, they only get this money, this MCP. These don't, these are out of the market. So they are in constant competition with each other. So electricity markets are playing that role. In India, we have three markets. Can anyone tell me what are they? So not markets, they are called exchanges or power exchanges. Can anyone tell me the names? So we have IEX, Indian Electricity Exchange. Then we have Hindustan Power Exchange. We have one more.
PXIL.
Yes, we have Power Exchange India Limited. Power Exchange Corporation of India Limited, but yeah. Right, so these three power exchanges, and can anyone tell me what is the quantum of power that is being traded in these power exchanges, cumulative? It's roughly 12 to 14%. So the total amount of power that is being consumed, only 12 to 14% of it is being traded in these power exchanges. You see how we as a market, we have to become more and more, we have to use a market interface. So right now, these the ministries and CERC, these all have come together to focus on market-based dispatch of these resources. So earlier, what is happening right now? There are power purchase agreements. So when a coal-based thermal power plant, let's say I want to build a thermal power plant, right? I won't build until and unless I know how much load am I going to cater. So what I do before building, I come to these retailers and ask, okay, how much amount of energy will you purchase from me at what cost? So all of them sit together, come up with a power purchase agreement, and based on this power purchase agreement, they come up with a power plant. So now these purchase agreements are huge in number, right? So they won't simply be like, okay, I don't want to take power from you now. I will disregard this PPA and I will go with power exchange. They can't do that. They can't dishonor the PPA as of now. So this will take a long time before this 12 to 40% becomes at least 50-60%, and it will take a very long time. But yeah, why these energy exchanges are being used? It's for retailers only. So retailers have obligations. So someone told RPOs, right? So what Indian government has done is they have asked, okay, each one of you discoms or distribution companies, in the power you buy, you will have certain obligations, certain renewable purchase obligations. So let's say it's 10%,
Two
right?
more obligations. There are
So
two more obligations.
RCOs
And renewable generation obligation and renewable consumer obligation.
so okay, we'll come to that renewable. So okay, RGOs and RCOs. But this is not okay. This is not for distribution company. Let me tell you, RGOs is not for distribution companies, right? It's not for
Yes, yes.
distribution. So I'm talking about distribution companies right now. So distribution companies have RPOs, right? So this RPO, what it says is okay, 10% of all of the power you consume in your jurisdiction. So let's say if I'm talking about Kanpur and my discom is KESCO, Kanpur Electricity Supply Company, right? So the government has placed okay, 10% of all the power you distribute in your jurisdiction, you have to take it from renewable energy. So this they have to meet irrespective of whether or not whatever their power purchase agreements they have. Okay, so this they have to manage. And how do they manage is a very different thing. We have to go to markets level, and I don't want to go over that. It's not the theme of this class right now. But yeah, in future classes, there will be a class on markets and what are markets doing and stuff like that. And there we'll discuss everything about this. Okay. And you have renewable generation applications. These are for your generating companies. So along with their power plants, they have to have some kind of a renewable generation operations going on, right? So they have some renewables like solar plants. I know this there is this um, what you say a generating company nearby. I visited once in Bharua in Madhya Pradesh.
40% generation will be from renewable energy. From
Hmm.
2025, it is mandatory to for thermal power plant.
Okay, 40% from 2025 for thermal power plants. Who is telling me all of
It
this?
is to generation from renewable energy.
Ranjit Pandey.
They
You
have
are
to.
doing MBA from NPTEL, right? So you will know everything about it because that's something that you have to do.
No, no.
Hey.
Recently, we have a semester paper on this,
Okay,
so I
okay,
know.
okay, okay, okay. Yeah, I mean, I work in markets, but I'm not in complete touch with what is happening in India right now. But yeah, that's nice to know that 40% of the generation from thermal power plants needs to come from renewable. So how is that going to happen? It's by they'll do something. They have this nice area, right? So they can have solar power plants or some kind of a power plant over there which produces renewable generations. But there is one catch which they can do. Does anyone know what is that one catch they can do to, not be able to install this renewable power plant? There is one thing called as renewable energy certificates. This Ranjit?
Yes, sir.
Yeah. So
I
what
know.
are RECs?
REC. REC.
Yeah, what are they?
Uh, one ton of carbon 1 ton of कार्बन जनरेशन फ्रॉम ऐसा कुछ है सर कार्बन जो जनरेशन होता है
Hmm.
उसका हम लोग ये देते हैं और 1 टन का कुछ ऐसे ही है सर अभी मेरे माइंड
वन
में नहीं
टन
आ रहा लेकिन कुछ
हाँ मतलब मैं उसमें नहीं जा रहा बट व्हाट मैं मतलब आई एम जस्ट
कार्बन जो हम
आस्किंग.
लोग एमिशन करेंगे उसका बीई जो है ब्यूरो ऑफ एनर्जी एफिशिएंसी वो आपको इसमें शायद ये करती है
ओके सो मैं बताता हूँ आपको क्या होता है रिन्यूएबल एनर्जी सर्टिफिकेट्स. सो
ओके
ये
ओके
वो नहीं होता जो तुम बोल रहे हो. दैट इज अ कम्प्लीटली डिफरेंट सर्टिफिकेट दैट इज कॉल्ड समथिंग एल्स. आई डोंट नो its name. But renewable energy certificates are those certificates which are given to renewable energy companies. What they do is, let's say I am a solar power plant. Okay, मेरे पास एक solar power plant है. I generate electricity and this is green electricity, right? This
ओके
electricity is green, right? But now when I sell this, I will sell it as a black electricity. What is black electricity? That is a coal based electricity. So black electricity. So these green electrons become black electrons and they are settled at annualized APCC. It's called na annualized um, purchase APCC. What is APCC called? I forgot the name of that term, but yeah, they are sold as a black electricity, and what happens is they are given in return renewable energy certificates for the amount of electricity they have sold as black. Okay, so they receive black electrons plus RECs. These RECs can be traded at a platform where these RPO or RGO obligated companies can come and buy these RECs to fulfill their obligations. So this is also one way in which you can escape, but yeah, these are very volatile because they are traded over as a market instrument, and in market the prices can be very high at a certain periods of time. So you want to hedge that, that's for sure. So this is something that is happening in India right now. So they want to focus on having RPOs for distribution companies or RGOs for generating companies to be able to.
This is
Uh,
all help us to achieve 500 gigawatt till 2030.
yes, this will help us, but we still have to increase our generation. We can't get away with that. That's also something that you will know NPTI, right? They have I had my friend. So from here, he went to NPTI for training. So he recently got placed at Seki. So he spent a semester over there. I thought you would know. Okay, so leave it.
In Faridabad or anywhere else?
Faridabad. NPTI is in Faridabad only, right? There is no other place for
Yes, yes.
NPTI.
No,
Yeah,
no. All over India there are 11 institutes.
NPTIs.
Yes, yes. NPTI there are 11 ठो हैं टोटल पूरे भारत में.
मेरे को तो सिर्फ फरीदाबाद का पता है.
नहीं
हाँ,
नहीं टोटल
फरीदाबाद.
11 है.
हम्म.
पूरे 11 है.
ओके, तो वो फरीदाबाद में था. उसने मतलब अभी सेकी ज्वाइन की है. ओके, दैट्स नॉट.
अच्छा अच्छा.
उसको वो करते हैं. सो
हाँ हाँ वहाँ पर आए दिन आपका कुछ ना कुछ का ट्रेनिंग वगैरह होते रहते हैं हमारे इंस्टीट्यूट में. जी जी.
So let's move on. So we discussed everything, right? So kaise now we have this renewable energies coming into scene. So we need smarter grids to be able to cater to these renewable energy needs, right? So now what is a smart grid? I already told you it's a conventional grid, but now with a brain. That is the definition I've come up with. You can come up with your own definitions, but in technical sense, these are highly efficient electrical grids with interoperate with interoperability as a central theme. So what they want to do is they want two-way communication flow across all channels. So they want two-way communication flows to happen across all channels. So your smart energy systems become power. So your energy systems, which were earlier power generation, transmission, distribution, they now are called smart energy systems, where they are in touch with each other using secure communication flows. Right? You see these blue lines. So these blue lines depict their secure communication flow. So there is an electrical flow, but also there is now an improved communication flow. So that is what the smart grid is all about. It wants to increase interoperability by communication, right? Also, you want smart information systems as well. So you want smart metering, you want smart meters at every homes for people to see what their consumption is in real time, and that is only possible using smart meters. Will come what do smart meters do next, but yeah, there is one thing, such thing as smart meters. You want sensors, you want to sense what is the voltage, frequency, or electrical current is at a particular node or a particular line. You have these phasor measurement units. I'll come to that, what is phasor measurement unit, later. And there is information management. So you want to manage all of this information. So you get this information, right? But you have to now manage it as well, and you want to send it to the people who are responsible to each and every information they need. So this information, this whole thing is comes under smart grid, and is dissected into different domains. Right? So transmission, distribution, generation, and customer, they were already there. Now we have added markets, operations, and service providers. So all in contact with each other, all in contact using some level of communication. But that is what smart grid is, right? This is what the smart grid what is meant by smart grid: interoperability, or communication between each and everything. So in this slide, I've just shown what are the major differences. You can see that conventional power plants, it was just one-way power flow. You're from generation to distribution, the power used to go vertically. It was just vertically integrated, and power used to go from generation to distribution. Now, with EVs, the solar power, and small wind turbines, people now have bidirectional power flows from distribution to generation, right? And to take control of this power, how will you know when to let go of one? If there is bidirectional power flow, your network could also become, violated at some places at some times, right? How will you know that? Until and unless there is a communication link between the load managers or service providers to know which node is affected at what particular point of time. So so now you want this distributed energy generation, which is happening at the distribution side, to be able to come into the foray, but with a communication link. So that is what is happening. So transmission systems now have smart control centers. So this smart word will come everywhere, because you want to distinguish how it is different from your conventional thing, right? It is smart now. What do you say when you say this person is smart, right? You say he's smart, right? He knows everything. How does he know everything? Because he has got a brain which he uses to his best capacity. So smart control centers, that means they are now smart, they have a brain. Smart power transmission networks, they also have a brain. Smart substations. And at distribution, there is this distributed generation that is coming: solar PVs, wind turbines. You have bidirectional power flows now, right? And you have also a concept of microgrid. So what is a microgrid? It is a standalone, it is a system which can support a standalone, it can provide the needs of energy need as a standalone, also as a also by being connected to the grid. So this comes from the fact that like for example, hospital, right? A hospital has to have, it's a critical load, it needs to have electricity at all times. So you'll see there are these diesel generators, they will have renewable as well now, for the solar PV cells, etc., etc. So they are now able to support their power on their own, even when the main grid is off. When I say off, it means not the blackout is happening, it's just that the power is not coming to the microgrid as of now. So they are self-sustainable in nature. So yeah. Now, what do I mean by smart monitoring? So I said here, right, there needs to be smart metering and smart monitoring. So what do I mean by smart monitoring? So I don't know if it has happened at your place, but at Jammu, so I come from Jammu, I'm from Jammu and Kashmir. So we recently have been given smart meters at our home. So we are able to check. So there is this dashboard, there's this application which has a dashboard which tells me how much energy I'm consuming daily and how much energy, and it gives me, when you tell a person, okay, I'm telling you how much energy you are using daily, you know your pattern, so you will be conscious in decreasing the amount of load you are coming up with now, right? So smart meters serve that purpose. They make the consumers intelligent with their own consumption needs. So that is where smart meters are coming into picture. So there is,
Also installed in Bihar.
oh, they're also installed in Bihar. Nice.
Yes, I have the application of a smart meter.
You have what? Oh, you also have an application. Yeah, that's
Yes.
nice. I don't know about UP, so I have never been to any place in UP. I don't know if they have, but in Jammu and in Delhi and some major metropolitan cities, they have smart meters. That's something that I know. So now, one thing I'll tell you, in these classes, I will not only be covering the basics, but I will also be talking about some useful concepts for you, right? So we should not be limiting ourselves to what has been taught in the class. We should also be able to, see what is happening in this research. At the end of the day, I do research, and I would love to talk to you about what is happening in electrical engineering as of now. Right now, people have come up with this smart meters. They have this data, right? They have so much data. So how can they use this data to convince the customer to decrease their load at specific points of time, right? So what they do is, they take their smart meter data and they take their electricity production data. Let's say you have solar PV installed at your home. They take that data, they do some processing, they detect events. So what is an event? Let's say you have data, right? So sorry, I'll draw it nicely. So at any given point of time, you feel like I should talk to you about something, you can just unmute yourself and let me know, right? So this smart meter data is something like this. Sorry. So you will have this, you have this, right? So what it does is this tells you at any given point of time how much your load was, right? Let's say it's P versus T. And these are just bar graphs, not like a straight curve line, it's bar graph. So what they do is you detect events. Let's say you switch off a bulb, right? A bulb which was continuously glowing from A for 8 hours, when it turns off, it leaves an electrical signature. Every appliance you use, everything that you use has a fingerprint, has an electrical signature. We call it an electrical signature. So some of that electrical signature, like say for example, okay, I turned off AC at 11 hours. So you will be able to tell from this bar graph when your AC was turned off. I mean, not you, but people will be able to tell you. And I'm just talking to you with a bigger picture. That's not what happens. There's a lot of analysis that goes into this while detecting events, but I'm just talking to you about the bigger picture. So you detect these events and then you want to do something that is called as non-intrusive load monitoring. So what is non-intrusive load monitoring? It's that without knowing what appliances you were using, without having connected them to a separate meter, you can detect their usage by just looking at the smart meter data. Just one meter which can tell you everything about your appliances. Now that's scary and that's wonderful as well. Scary in a sense, let's say your smart meter data, it's released to public, people will be able to tell what kind of loads you are using, right? And it's wonderful because now you know how much electricity a particular appliance was consuming, and you will be able to tell, okay, I should switch off this device because it consumes electricity during this time of the day, and I don't want to use it this time of the day, right? So using this NILM and event detection, you can do a kind of, I'll start with second thing, first, last. Load profiling, you will be able to tell, okay, let's say I want to talk about my what you say, a refrigerator. Okay, so refrigerator is a cyclic load. What is a cyclic load? It does not stay on for 24 hours. It stays on for 2 hours, then stays off for 2 hours, then stays on for 2 hours, and then stays off for 2 hours. It does not continuously provide cooling, right? It turns on, turns off, turns on, turns off. So based on that, you will be able to profile each and individual load. Your light bulbs, which are continuously glowing, your washing machines, your microwave, refrigerator, everything. Based on this data, you can also do load forecasting. Now you have this data, right? You have the data for the past 1 year. So you will be able to tell, okay, in January, I won't be using my AC, but I will be using a heater. So I know the heater won't use that much amount of energy. So you would be able to tell, okay, you would be able to do forecasting based on this smart meter data. Then you have demand side flexibility, something that you can also use. What is demand side flexibility? It means modulation of power. Let's say I, as a discom, tell you, okay, I will give you 100 rupees. Don't use your AC during 12 to 2 p.m. Okay, your AC usage during 12 to 2 p.m. is causes me to get electricity at a very high price, and I'm willing to pay 100 rupees. So because the company knows you use your AC during 12 to 2 p.m., it can offer you incentives to have some flexibility in your demand. You can also detect patterns and anomaly, right? Patterns in the sense that you can detect, okay, I am using AC for a very long time, your refrigerator, your washing machine, etc. Anomaly, let's say someone else is using your electricity and you don't know. There is this thing that is very prevalent. People take electricity by using some equipment. I don't know what it's called. So you will be able to tell, okay, if my energy is being used at a place where I don't want it to be used, and it can be used to give user feedback. So these discoms will be able to tell you, okay, you are using a lot of energy and your neighbors are using only this much. So now you will be, You will be pressurized. It's called peer pressure to decrease the amount of energy you're using. So that is something that smart meters are now enabling. So this is
Sir,
what. Yeah.
look at
Look at. What did you say?
my video is on. You can see the pattern of.
Just a second. Let me see for everyone. Show me. Oh, nice. Yeah, that is what I'm talking about, right? Bar graphs, and you can check, but it won't be for the daily 24 hours. It will be for it's on a per day basis or 24 hours.
No, per
Sorry,
month, and
sorry.
you
Is,
can
is it hourly or a daily or monthly?
daily. No, this is monthly.
Monthly, right? So you can you get it till hourly? No one supports that. I too don't have hourly information. You have hourly? Uh, I can't. Yeah, now I can see. Oh, you have hourly. Nice. Your smart meters are much better than mine, yeah. Nice, nice. So see, based on this data, you can collectively know what kind of appliances you are using, right? So you can do, I mean, if you
I can
want,
recharge also my
okay.
this this allowed to also recharge.
Oh, okay. Yeah, you have to recharge. You have to prepay for electricity now. Yes, yes. Okay. Great. Great, Ankush. Thank you for demonstrating it to people who don't have smart meters yet. So now, you see, this smart meter is now it's now prevalent for India at least. It's prevalent in Western countries, and it's now getting prevalent in India too. So now let's come to one other thing. I told you I'll talk to you about later. It's in monitoring. You need to be able to measure your your quantities of interest, right? So what are your quantities of interest? It's your voltage and your frequency. You should be able to, you would want to know current as well. I'm just taking voltage and frequency into account. Current you can always get by doing some calculations, right? So you want to generate this quantities, right? So how you can do it? It's through phasor measurement units. So these phasor measurement units, also called as PMUs, these are called eyes and ears of the grid. Such a big term to give to such a small, yeah, eyes and ears of the grid. So they are used to gather information from any node at any given point of time. So they continuously supply data, and they enable the operators to have real time monitoring, right? So they can do real time monitoring sitting at a different location. Let's say I am at Kanpur. My grid's office is at Kanpur, but my generating power plant is at Lucknow, and I want to get information over there, right? So you want it to be displayed in real time, so you can use a PMU for that. What do PMUs use? So they make use of one important thing. They make use of referencing. What is referencing? They take a reference signal. This outer circle, you see, I'll just use a pointer. So this outer circle, they call it as a reference, and based on the how much this reference is a perfect, it's a perfect cosine signal, a perfect cosine, right? You can see from this diagram, it's a perfect cosine, and they measure how much lag the voltage is doing from the reference signal, right? Based on this lag, based on this delta, they develop this phasor representation. Similarly, from, let's say, this bus 1 and bus 2 are connected, and these are the signals that they are getting. So this is how the phasor representation will look, where the rotation will tell you about the frequency, and the extension of this arm will tell you about the magnitude of that signal, right? So this is how phasors are being incorporated, because they can tell you a lot about the signal by just giving you an interpretation of what is lag and what its magnitude is with respect to a reference signal. Now, how do they work? How do PMUs work? It's also very, it's not like it's a very easy thing to create. These PMUs have gone from a very, what can I say? They have evolved over a very long time, right? So how is this managed? So our voltage and let's say current, these signals are analog in nature. So right, your measurement devices, they are analog and they give you analog information. What is analog? Can anyone tell me what is analog? What is an analog signal? Okay.
It is continuous
Yes.
signal.
It is a time continuous signal, right? So this time continuous signal is then sent to anti-aliasing filters. So what they do is they remove high frequency distortions. So your signal will have distortions, it will have disturbances, it will have noise, and they reduce high frequency noise, right? And they then send it to a high precision 16-bit. 16-bit is a very high precision, right? As your number of bits increase, your precision increase to an analog to digital converter. So they convert this analog signal to a digital converter, which is then phase locked. What is phase locked? It's just you have a GPS. Let's say this is your reference signal, right? So you want to timestamp that signal. Sorry, reference signal is here, and you want to timestamp, right? It should not be like I'm sitting it at IIT Kanpur and I'm using my watch, and my watch says, okay, it is 16:22 right now, but your watch will be saying it will be 16:21, right? 6:21. So this should not happen. The time lag should not be there. So what we do is we use a global positioning satellite which tells you about the time and then timestamp that with the phase of the system, right? So your reference signal and your digital signals are then phase logged, and these are then sent to a microprocessor which performs mathematical manipulations to converting them to phasors. And these phasors are then sent to modems, which are then transmitted to different entities, right? So these send these signals to different. So this is a communication system, and they send it to operators. So this is what a PMU is. It's what its job is. Its job is to send the for a given node. Let's say I connected to a node where my generating station is connected, right? And I'm sitting at Delhi and my power plant is in Kashmir. And I just do one thing. I use a phasor measurement unit, install it over there, and sitting at Delhi, I can do a real-time monitoring of that system. That is what is done using phasor measurement unit. These are very, very highly required. Right? So I shouldn't say very highly, but they are highly required to increase the efficiency of the system, to increase the reliability of the system. So in smart grids, so I've talked to you about, okay, am I missing something? Okay, let's move on. So in smart grids, I've talked to you about, okay, there is a lot of communication required. You need communication system between everything. The infrastructure needs to be very, very resilient to any kind of thing, right? So there are two kinds of communication system. One is wired, one is wireless. In wired you have power line communication cables, and fiber optics. So fiber optic, sorry, PLCCs, they have Mayur Gupta has raised a hand. Okay, Mayur.
Yeah, probably I'm asking it a little bit early, but I just would like to understand the application, I mean, practical application of PMUs.
Practical application.
I mean, the means the end result, what do we derive out of it?
What okay, okay.
I mean,
Let's
say example, no, in our distribution system in Reliance, we have this PMUs installed everywhere.
distribution
How
system.
can we
In your distribution system, that's not a
in the
PMU, that's
industrial,
a micro
in the
PMU.
industry?
That's a micro PMU.
Micro, it's not a micro PMU. It's a very big distribution system of
Oh, it's a
1.3,
big
1.5 gigawatt. Yeah, yeah,
okay,
yeah.
okay, 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 okay,
So
okay.
it's we are talking about the biggest
I
refinery in the world.
okay, okay.
So it's a very huge system.
Mm-hmm.
So, but we have PMUs installed, but even though we haven't I mean, practically used it, to be frank.
Okay.
Yeah, that's, yeah.
Let me tell you. Okay. Let's
Yeah.
say that you are operating a very so PMUs right now PMUs, they are used for transmit at a transmission level. I'll tell you why. Let's say you have sectionalizers at some place, and you experience fault at that location. Sitting at Delhi, monitoring the situation which is happening in West Bengal, right? Let's say there is this extensive transmission system, and over there, a sectionalizer switch has to be used to sectionalize two lines because there is a fault that is occurring. You know, how would you get to know about that when you're sitting at Delhi? You're sitting at a remote location. You don't know anything happening in real life. You don't have eyes on that system, right? So what you can do is you can get two things out. You can get the phasors or the measurements out of that place, right? You need voltage, you need current. If you get those two things, you will see that, okay, these are not behaving as you want it to be. So that means there is a fault that is occurring at that system, and you need to isolate that fault. Otherwise it can cause huge damage to the system, right? How will you know? You can only know it by having some kind of measurement unit device placed over there. Earlier, there were devices. There were this called RTUs or something that transmitted these signals to a wide range. But phasor measurement units, what they do is they provide concise information, and they can send it to a very large bandwidth, to a very different location altogether. Okay, so you will be able to tell based on the real time values that are getting on your system. Okay, right now it was 1.1 per unit, 1.1 per unit, and I don't know why it just went to 0.75 per unit. So you will know, okay, there is something that has happened to the system over there, and you will want to use sectionalizers to sectionalize those lines, to create sections of those lines, so that fault does not propagate further down the line. So phasor measurement units, these play a role in that sense. So that's why I called it eyes and ears of the grid, because you don't have to be physically present over there to see what is happening in real life. You can just watch those values take shape or turn into such different figures, which can tell you, okay, this is not something that should happen. I should, yeah, go ahead. You don't
Yeah,
have to raise your
sorry.
hand. You can just
No,
unmute yourself.
I
Yeah,
didn't want to interrupt you. That's why.
yeah, okay.
So, yeah. So, but there are already protection relays in place, which will take care
Protection.
of all the protections
Yes, yes,
in the local.
yes.
In all the bays, there would be maybe if not differential distance protection and all those fast tripping schemes. So why would I want to isolate it sitting in Delhi with a PMU?
Okay.
Whether or not a protection system is more reliable, definitely years together we have been using that, and they are very reliable. There are redundant relays and all those things. Why would I want to use such a PMU thing to isolate from remote location? Um,
I just gave you an example. I'm not saying that you have to isolate. I mean, obviously, if your protection systems are the ones that protect you, that if they are not, if they're not reliable, then what's their use? But it's just an example that I gave. Okay, if you want to manage a system sitting at a different place, right? Let's say, for example, let's say that take the example of Grid India, right? They want the complete picture of what is happening at all the buses of the systems, right? How will they do? They can only do it if they have data coming from directly from the node at which the PMU is connected, right? So if
mhm.
they have some device connected at that node, they can transmit that data to their system sitting in Delhi, right? So they don't have to call ERLDC. Okay, what is happening to that transmission system over there? I can't see, I don't have eyes on it, but
So
they
whether
can.
they are looking at the sorry, I'm interrupting.
No, no, go ahead.
Whether they are looking at the reliability perspective or security perspective,
Okay,
or
so when they were made, their real purpose was to adopt real-time monitoring. That real-time monitor the situation of things. That is what their purpose was. Now, when you develop something, you increase its utility in other things as well, right? So you want to create a bigger picture of I'll come to the later term. It's called wide area situational awareness, where you have a very large geographical spread, right? And you want to keep everything at a central place, at a centralized location. How will you do that? PMU is the answer. So it's like it can be used in many ways, but yeah, right now it's only being used to monitor the situation in real time.
so there is a concept of grid security also, where you have a normal mode of operation or emergency
Yeah,
mode or a
emergency.
abnormal mode of operation. So whether that kind of, because I read one of the IEEE paper also, I mean, this, whether this kind of implementation of PMUs can be used for transiting between the states, or indicating a distribution owner, or people like us who are operating a very large industrial network, that the grid is moving towards instability, or apart, because the parameters normally what we monitor is the frequency voltage, and those
Frequency voltage.
normally
Yes.
those are all protected up and down, like there is over under frequency tripping and all those load shedding, and voltage is also, equipments are protected by over under voltage trip. So apart from that, how does the PME, I mean, I'm not able to get the answer for that, whether how does it add a value
Okay.
to, or whether how can we derive a value out of that system?
Okay, let me think of a perfect answer for you. So you talked a great thing that, okay, from grid security perspective, that voltage frequency, if it violates, it transitions into a different state.
Theoretically, I have seen, but practically, when we even see in the market, no, we don't see people working on it. I mean,
PMUs.
we don't find a solution in the market for such things.
For what market? PMUs, right?
Market means, I mean to say, some vendors like ETAP and those people. No? There are so many different members like ABB or Snyder, or people are not offering such solutions where you can see the the state of your power system.
Yes.
Uh,
So
Till I haven't kind of come across. I mean, there could be,
So
I don't know.
I can
Yeah.
tell you one thing. So that state of your system, that diagram that you're talking about, now, that normal, emergency, and
Yeah.
restorative. So
Correct.
that's not the only image. So it's called Jericho or some kind of a diagram. It's I forgot its name.
Delhi, yeah, D some
Uh,
scientist has
some
invented.
sometime, yeah,
Yeah.
but that's
Yeah.
not the only state of the system. So that is a very, very, very basic model. So there is a different model. There is a different concept where there are more states than you can even.
Yeah, that I have seen. I'm
Yeah,
aware
it's
about
a
it.
very extensive.
More
Yeah.
than
So
four, or there are six,
yeah,
seven
yeah.
states, something.
Yes,
Yeah.
yes. So what my point is to you is that each and every state, or each and every state at which a grid comes due to some kind of some voltage going out of bounds or frequency going out of bounds. Yes, you have under frequency relays, you have all of this in the system in your place, right? But they are working with values, right? With values. So see, I can tell you one thing, that earlier what used to happen, your you want to decrease the amount of physical, or the physical layer, you want to decrease the manpower that is required to monitor all of these things, right? So let's say there were earlier control centers at each and every location to monitor what is happening at a particular grid station, right? Now you don't require that manpower. Why? Because PMUs are there, which can transmit centrally to a different location, or centralized location, right? So PMUs come into place where they can help you in many ways, but yeah, their only purpose was developed to monitor the real-time situation, real-time monitoring. Coming to the grid security perspective, the system behaves very different ways during any given state of the system. You don't know when a brownout is going to happen or a blackout is going to happen based on just those three states. It can straight away go from restorative to blackout, or from restorative to normal, depending on the quantum of power that is shed. So that developing a tool which is able to tell you about that, I mean, go ahead. People are doing it. It's a nice I mean, research area. In our IIT Kanpur also, we have developed PMUs for purposes of distribution systems. So micro PMUs are what they are called. In IIT Kanpur, we have developed that. It's patented as well. I don't work on it. My fellows work on it. But yeah, my answer is, people are employing this for varying different purposes, only to monitor the situation in real time, so as to decrease their manpower load, so as to monitor what is happening at the system in real time. That is the only example I can think of. But what your perspective is, it's completely different to what I have understanding of. You come from an industry place where you want to have utility of things, right? We come from a place where nothing is sufficient. We have to have something to make it more valuable, right? So utility, it's left to the industry people to figure out what is the utility of a given thing. But yeah, real-time monitoring is what it was made for, and it is still being used for real-time monitoring only. Yeah, go ahead.
Okay. Yeah. Thank you.
Yeah,
Thank you.
no worries. Yeah, I hope I'm able to answer, but yeah, I'm also a student, and
Yeah. No issues. I mean, this is what I could not find the answer. That's why I asked it.
I will make sure to
Nothing
get
more
an
than that.
answer to you by next meeting. Why? Because there are professors working on PMUs only, how PMUs should be made. I can ask you what is the utility of this, and I'll get you an answer to that. I mean, you will be
Yeah.
hearing
Okay.
from me
Thanks.
soon.
Thanks a
Yeah,
lot.
yeah, sure.
Thank you so much. Thank
No
you.
worries, no worries. Okay, so where was I? Yeah. So you require communication protocol, you require communication systems, right? So all the smart grids, it's all about in using or interfacing different entities with a communication link, right? They can be wired, they can be wireless, and that's not it. Okay, you can't have certain degree of freedom everywhere. You have to have some set of rules, some set of written specification according to which you have to work. So standards govern that. Standards are rules or technical specification. Uh, okay, so technical specifications that provide you with mechanisms to operate, right? So I'm not giving you word to word. I'm just giving you what I feel should be an answer. I mean, you should all know a perfect what is the perfect definition of this. I never really understand the theory that what is a perfect explanation or perfect definition. Whatever you get from it, you can write it in your own words, right? So yeah. So there are two main standards. I mean, not there are many standards which are used in smart grids, but two main standards that we will be focusing on. One is IEEE 14547 and one is IEEE P2030. So IEEE 1547 basically is used to develop guidelines for interconnection of DERs. So this gives you interconnection of DRs. And P2030, it sets rules and guidelines for interoperability. So it develops three layers: physical layer, communication layer, and ICT layer. Right, ICT, I'm sorry. ICT is communication, and I should say cyber security. Okay, so these two standards are very specific for your this smart grid. You must have, it's just a review class. You must have covered in the class itself when you've gone through those video lectures. But yeah, this is what they are used for. Basically, IEEE 1547 lays down ground principles that each DR interconnection must follow. Like for example, it specifies grounding approaches for your microgrids or your DRs where they are connected. So how so that they don't they don't create voltages which exceed the rating of the grid, right? So that is one. And then you have how much of voltage can you influence at a point of common coupling. So at a point of common coupling, they tell you that only plus minus 5%, that is the only amount of voltage that you can influence. If you're influencing more than that, what do I mean by influencing? Is that you shouldn't cause fluctuations at that node, right? So let's say you have connected a solar PV power plant, right? And it's very varying in nature, and you have not connected anything to smoothen out its output. So you're causing voltage fluctuation. So it tells you that it should not be greater than plus minus 5%. These are some rules that they tell. I will ask you to, if you want to know in extensive manner, you should read the class notes. So class notes are different, this lecture is different. And these are the domains of the smart grid. So smart grid, I already told you, it operates in different domains. So these domains talk to you about the different uh, uh, different people or different set of organizations that are there in the smart grids domain, right? So the first is customer. So customer is the domain, like for example, you and me, residential, business, industrial, all of these are customers. And for that, what they have is they have AMIs, which are it's called advanced metering infrastructure, and ESI, which is energy service interface. Is it correct? Is it energy service? I have a question on it. Yeah, energy service. Okay. So advanced metering infrastructure, it's like automatic meter readers, smart meters. They should, for a smart grid to be called smart grid, the customers should have these things. An energy service interface, let's say you want to have solar PV rooftops on solar PV panels on your rooftops. You want them to be connected to the grid. You should have ESI, energy service interface. Next, you should have markets. I told you they lead to uh, true price discovery, and they are inherently a part of your smart grid domains, right? Then you have service providers. They deal with business end of things, billing management, and they do account management for suppliers and retailers. Then you have operations, which deals with control, monitoring, planning, security, analysis. So operations is like you want the grid to be secured. It should coordinate between different resources. So that is what happens in operations. Then you should have a distribution system that can have DGs. It should be transmission. It should be linked with the customers which possess renewable energy resources, and it should be able to tell you the dynamics of the distribution grid. Then transmission, you already know what transmission system is. ISO, if you're new, ISOs are independent system operators. So in India, ISO, you can equate it to Grid India. So these operate the transmission system. And then you have generation. So generation should be linked with markets, and they should be able to and also transmission system, and also the generation, this pumped storage. What is this pumped storage? This is something that is coming into build now. So what is pumped storage? So let's say batteries. So what do batteries do? At periods where the electricity is low, you want to do arbitrage, right? Or let's say that you have what you say, solar photovoltaics or solar PV cells. And what you want to do is, when they are producing less, you still want to supply electricity to the grid. You can always use energy storage. And when they are producing more, you can store it in the form of energy storage, which you can use later on and trade it later on, right? But batteries are expensive. All of us know that, right? So now people have come up with a new thing. They call it pumped hydro. So what does pump hydro do? Let's say you have this small hydro plant. Here is water, and here there is, let's say, reservoir, and you have certain mechanism to push this water. You have relays, right? So you have relays to push this water. So what you do, so instead of storing energy in a battery when you have high energy, what you do, you store it in the form of gravitational energy. You pump water to a reservoir, right? You pump it, and then when when energy generation is low, you supply this water back through a turbine. And when it hits the turbine, it does the same principle as hydroelectric power station. It rotates the turbine, it generates electricity, right? And you do this just as if you are doing it with a battery. So this is something that people have come up with, pumped hydro storage plants. Yeah, I mean, these are not something that you use in your homes. but people are doing research on that as well. But I don't want to go into that. But this is something that people are coming into are doing. Mainly, these generating companies want to do this is to modulate power. Yeah, go ahead. You don't have to raise your hand. You just have to unmute yourself. Okay, nobody is doing that. So they want to modulate power to influence frequency, right? So if you all don't know, in power and frequency have a direct relation, right? As I told you also, supply and demand balance. If power increases, if the net power you have increases, your frequency will increase. If the power is less, your frequency will decrease. So power and frequency have a direct relation. And this is what people have come up with. It's called pumped hydro storage. And now there is one more company which is incubated at IITK. They are not working on this. So like water is something, it's a resource, right? You would want to use it at different places as well. What they have come up with is called gravitational storage. So they're what they are doing is they are using sand as a medium. So they are pushing sand up and back through the turbine. So sand is not replenishable, right? Water can, if it's a very hot day, water can evaporate, but sand won't. So that is something people are doing. It's called gravitational storage system. So this is people generating companies are coming up with to modulate power frequency. And why is this required? It's because of varying net load. Your renewables are causing a lot of variability, right? So these are the that is why these are the some grid domains, and I don't know why this slide has repeated, but as I told you, standards of smart grids, they set rules, guidelines, and for safety and economic purposes. And interoperability of smart grids, they want smart communication, you want to scale up new systems, you want them to be secure and customer friendly. And these are some of the standard developing organizations. Mainly, we'll be using IEEE standard systems for our purposes because this is the only leading organization that works in only electrical focus areas. So smart grids had different standards. There's interconnection of grid, IEEE 1547. There is time synchronization, something called as IRIG-B. I don't know the exact, it's abbreviated form, but the standard that supports this time synchronization is IRIG-B. Then you have wide area situation awareness. I'll come into that in a bit. You want to do substation protection and automation. You have 61850, I guess, IEC 61850. You have cyber security protocols. So you have many of them. You don't have to remember all of them by heart. Just two, which I told you, 1547 and P2030. Right? I also don't remember all of them. Nobody needs to remember these. You can always search for them. Now, what is wide area situational awareness? So this term I've talked about 2 times, I feel. So as I was talking to, I guess his name was Mayur. Yeah. So Mayur, that if you have a very large geographical spread, right? So you want to be aware of the situation at all given point of times. That means you want to be able to remotely observe the different power system components. And for that, VASA is used. It's called Wide Area Situation Awareness. Here, PMUs play a central role. Right. So this is what VASA is. It's also it also comes from there are also standards laid down for how to operate a wide area situational awareness, and there is something as also called as wide area monitoring infrastructure. I don't know. So this is something that is not taught in this week's lecture, but yeah, this is something that you should remember, right? And these are all of the yeah, I was correct. 61850 and IRIG-B. IEEE 1547. This tells you what is the point of common contact. Point of common coupling, and LAES, which is it's called local area power and energy system. You can always relate it to microgrid. I don't know why they call it LAPS in this. And then there is IRIG-B. I forgot its abbreviation. I'm sorry. I should have already put it over there, but yeah. So for VASA, there is one standard which is called IEEE C37.118. It's related to the use of total vector error of PMUs, right? So when PMUs send you some value, right? How will you know if that value is correct, right? So you want that value to be within some certain range. It should not be like the voltage is over there is 1.5 per unit. Sorry, it's 0.85 per unit, and your PMUs are sending 1 unit, right? 1 per unit. So that means there is some error that has creeped in. So total vector error, it specifies that this total vector error should be less than 1%, right? 1% of steady state. So I'll talk to you by why steady state. So so these come with a resolution of, let's say, microseconds, right? So you have 1 millisecond or 2 milliseconds, all of these information is getting transmitted to you. Now there can be disturbances, right? So you don't want these disturbances to be also treated as a total vector error. So in a steady state that is taken 5 minutes at a time or 15 minutes at a time, how is my vector looking? So this total vector error should always be less than or equal to 1% of steady state. Then you have IEC 62351 for cybersecurity protocols and IEC 61850 inter-range instrumentation group time code B. Very good. Inter-range instrumentation group. Great. Thank you. Who was it? Mayur. Thank you. So, I'll write it over here so that people don't have inter-range intermission instrumentation. Why it's not visible? Why group B? I forgot group time code B. I don't know. It's fine.
I don't know. I don't know.
Yeah.
I
These
know Eric
standard.
B, but we used it also. But I first time I never thought that it has acronym. So
Yeah.
just now I went to.
So yeah, the standard supplies that the accuracy should be 1 microsecond. That is something that I've written, but I don't know what code B is. I remember going through it when I was doing my coursework, but I've forgotten everything now. Yeah. So let's come up to one thing, two more things, then we'll discuss, and then we'll move on to questions. Questions will be very quick, so we don't have to put our head to it. So all I was talking about during this time was smart meters and advanced metering infrastructure, right? So what exactly do you mean by advanced metering infrastructure? There's also some standards that govern what has to be there in your system to be qualified as an advanced metering infrastructure, right? So let's say that you have some measurements, let's say voltage or current or phasor or power factor, your power component, active power component, your reactive power component, or your energy usage, right? So these come from your smart meters. These are some measurements that come from your smart meters. And these then go to an automatic meter reader, which sends it to your respective distribution companies for billing information, right? But these are also sent, just a second, 39%. So these are then sent to some form to your to a place where these are managed by your discom, so that they can check if, let's say, some years given some time from now, if you require some infrastructure upgradation or something like that, right? So these are sent to your meter data concentrator, we call them, using a neighborhood area network that can be a PLCC or a radio frequency of 900 millihertz. These are sent to meter concentrator, where all other smart meters send information. Smart meter 1, smart meter 2. So these send, and they are then concentrated over there, which are then sent to a measurement database management system, right? These manage the database of the whole measurements that these smart meters have provided till date, right? And the meter data concentrator is responsible for communication between your smart meters and your meter data management system. There is one more thing called as head end system. It is responsible for, it's a very wide hub, right? It's a very wide area. A distribution system is a very wide area. So head end system contains, it acts as a main hub for all the customers, connecting all of the data from all of the distribution feeders that are there connected to your discoms. So this is what an advanced metering infrastructure does. It stores your meter data so that it can be used to develop certain algorithms or feedback for the users to be provided. Like for example, this guy who was showing smart meter data, how does he know, right? It's not like smart meter is just plugging it over there. It is being sent to a location where it is getting processed and then being sent back to you. Same thing is going on with the distribution system, right? Distribution systems are now getting automated. What do you mean by automation? Let's say renewable energy resources, these are increasing, right? Your solar arrays are coming, you have distributed generation and stuff like that. And now you want to be able to automate your already present systems to be able to, like for example, you have a switch connected to a feeder. You want to automate that, right? You don't want to be able to be there and just plug in and plug out. So this distribution system automation takes care of that by using three central things. One is SCADA. It is the supervisory control and data acquisition unit. Control. Then you have intelligent electronic devices. So these are nothing but these can be your relays, your systems, which are connected to your switches and stuff like that. You have RTUs, which are transmission units. I forgot. Very transmission unit. I forgot the
Remote terminal
yeah,
unit.
remote
RTU is
terminal.
remote
Yeah,
terminal
remote
unit.
terminal unit, right? So what they do is they support transfer of data from a particular location to a different place, right? And same stuff, IED. So PMUs is replacing IEDs and RTUs collectively. So it is like it's replacing them in certain sense that now you require only one PMU to manage everything. These are called phasor measurement units. Of course, when you come into low voltage distribution systems, you call them micro PMUs.
That statement is not correct, in my view.
Which statement?
IED and PMUs are replacing IEDs is not correct.
No, not IEDs. It's not like your switches will be replaced. It's like remote terminal units. What they do is they take this data from what is coming from the IEDs and they transmit it to a different place, right? You require only PMUs now with IEDs. Of course, IEDs will stay there, your switches will stay there, your relays will stay there. You still have to coordinate based on the information that you're getting from a particular node. But RTUs are the next best bet is PMUs. That's what has been taught in this week as well. But correct me if I'm wrong. I'll be happy to be corrected.
As PMU will measure the voltage and phasor and current max, and that is the data which it will send,
Yeah,
right?
yeah,
With respect to GPS time clock. So they are
yes,
all synced and all those things.
yes.
So, but RTU conventionally is utilized for even the breaker status, the topology, the network configuration of a substation or a power station. There's so many things which are transmitted via RTU to elsewhere for so many reasons.
Yes.
So that would be the difference.
I mean,
Uh,
yes, you are correct. I mean, RTUs are, in a sense, they are used for a wide variety of purposes. But in an automation system, the micro PMUs are what they are calling is it's like they are currently, so RTUs will phase out. That's what I have always heard from people. But yeah, I mean,
so PMUs have capability to transmit even the digital IOs, like the breaker status, isolator status,
yes,
or
yes,
say the tap position. Then
yes.
I'm
So
not sure. So
so
if
what?
that's there, then you are right. Yeah.
Yes, why? Because even with the analog signals, they are first converting it to a digital signal, right? So I feel
Let
if
us
they're,
see what you are saying. No, analog, digital, all this is done in ID everywhere. It's
yes, I'm,
not something special done in the PMU, the only special part of PMU, it's a time sync GPS.
Yes,
There is
yes.
a,
This the only thing
and you
difference
get
between
hmm,
RTUs and IDs is just the time synchronization. Yes.
time sync, and all IDs are time sync now. All devices, all the relays are known as IDs.
Mm-hmm.
Any protection relay you take, any manufacturer, Siemens, ABB, Areva,
Mm-hmm.
all they call it as IDs. They are
Yeah,
multifunctional devices.
relays, or anything that can be, switches, relays, everything is ID. Yeah, perfect. But and they're time
Yeah,
synchronized as well.
and they are
But
all time
yeah,
synchronized and with
but
the
they don't transmit.
Rigby.
Yeah,
Yeah,
but they don't transmit information.
they do transmit information on IC 61850 protocol, the
They
substation automation. Yeah, yeah. They do transmit. There are differential protection relays which transmit information over hundreds of kilometers for transmission lines. So, I mean, the PMU application understood is very specific to voltage and phase angle measurements, that
it's
particular
monitoring.
bus,
Yeah.
and then monitoring purpose.
Hmm.
That's my view. I mean, I'm still exploring this.
Yeah, I mean, see, for example, when things, so even if you say, like, for example, yeah, I mean, you're correct. I mean, IEDs are being used and they have been time synced. Obviously you need time sync. If let's say you're some relay has what do you say? It's being used, or it's being used at some place. You want to know at what timestamp it has been used, right? So yes,
Yeah, because
IEDs
see,
had.
whenever any event
Yeah,
happens,
any event happens, yes.
any event happens, multiple relay operate.
Yes, but
So to finally conclude what exactly happened,
Mhm.
so you need all the data in a time sync format. Otherwise, you will not come to conclusion.
Yeah,
What happened first.
yes. But what I feel is, like, for example, the standards that are now coming into picture, they are more focused uh on even with the smart grid standards, they focus on PMUs as the next best thing. I don't see IEDs, RTUs being talked about. That's what I have
Hmm.
observed. That's what I have observed. But yeah,
Okay.
they are still being used. I mean, it's not like IDs are not being used. You can't operate a relay
No,
without an
ID
IED.
means the ID is a regular term for
Yeah.
used even for any digital protection relay.
Yes.
So PMU cannot replace ID. I mean, it has
Hmm.
its own application.
It cannot.
ID may be a differential protection over current or earth fault, or even the bay control unit BCU for the
Hmm.
bay. All those devices which have a communication capability, which are time sync, are all known as ID, which are multifunction applications. One relay is not only for overcurrent protection; it is for overcurrent, earth fault, differential. There
Hmm.
are 15, 20 different applications. You can take any relay, Siemens, ABB. They have
Hmm.
multiple applications in it. Those are known as ID, which have multifunction communication capabilities. They are intelligent in their own sense, and they have capability to adapt even to the change in the settings if need be based on system configuration. So that has a different application. PMU has a different role altogether. So the not, I can agree with RTU. I'm not sure if the PMU has those capabilities of sending the data to capturing the digital IOs also and then sending it. Then maybe they can replace the RTU.
Yeah, I mean, what I've heard and what I've, so it's all knowledge that I've gathered. I don't have practical experience. Obviously, you will have.
Yeah, I'm just mentioning whatever practical experience I
Yeah,
gained.
yeah, you have practical
Okay.
experience, so it's nice to know,
Yeah.
that about that. But what we get from theoretical knowledge is that people are in they are in places where they are just wanting to use IEDs coupled with PMUs, not RTUs. I don't know why. I haven't really gotten into the crux of it. I never really thought about RTUs being better than PMUs, because PMUs came as a very small device to transmit, to create phasor measurements, which can just give you the state or health of the system just by looking at
Correct.
those
Correct.
two phases, right?
Yes. That's what I understand
Yeah,
also.
that's the
Okay.
only thing. But now they are trying to, it's the RTUs to to transmit instead of using RTUs, they use PMUs to transmit this
Yeah, see
information.
what happens, no? They when they make a relay,
Mm-hmm.
they put a controller and then they put so many IOs.
Yes.
The same motherboard can do multiple functions.
Yes.
You can put more IO cards and then have multiple functions without. Now there are so fast processors available,
Mm-hmm.
and the computing power is available.
Mm-hmm.
So they do use it for multi-purpose. So a PMU device can function as a RTU, data collector also. So that
Mm-hmm.
is possible.
Okay. Yeah, you are correct. I mean, I really have to dig deep for this. I mean, but yeah, that's nice to know that there are some things that I don't know that I should really look for, and it's nice coming from you. So, which industry do you work in? Reliance, right?
Reliance, yeah.
Reliance in which vertical?
In Yeah, I'm in energy, power, and steam in
Okay.
Center of Excellence in Clark. This time I'm just attending, so if something new, I will learn also.
Oh, okay.
It's the same way. So there
It's
are things I don't know also. It's not like that.
okay.
So
Okay.
it's
Yeah, so from I will love to get back to you. I mean, this is a very
yeah,
nice
yeah,
and
sure,
interesting discussion as well, because I never thought
sure,
of it in
sure,
this way. You know,
sure.
when you have knowledge, bookish knowledge and theoretical knowledge, you just seem to use it for a fact, because I have never seen an RTU. How will I know it's not better than PMU, right? You've seen
Okay, okay.
everything, so you will know better. But yeah, that's a very interesting thing to learn. And I'll get back to you for sure.
Yeah, yeah, okay,
Okay.
okay.
Yeah, so where was I? So yeah, everything in whatever is meant by automation, it's just that we are adding a communication layer on top of the physical layer, right? So now all of my IDs, which were also in earlier in contact with the through RTUs, terminal units, terminal units. So these are now these IDs which are connected to your switches, your sectionalizers, your closers, your capacitor banks, your transformers, and whatever it is, your main switches, circuit breakers, everything. These are now in in cahoots with each other using a communication network, right? And all of this is has to be supplied to a data concentrator. So you can't just measure each and every instant. Like for example, it needs to go from some place to the other place to be made it to be made readable or legible for you, right? So that is where distribution automation is coming into play. Next week is specifically dedicated to smart meter sorry the smart distribution systems and transmission systems and monitoring. So we'll discuss, I feel we will be discussing this whatever your things were in detail about PMUs and all of this wide area situational awareness and stuff like that, right? So that was all for this week, and we'll now move on to this week's questions. So we have to have you practice some questions so that you can answer your assignments. So now, who can quickly tell me the first question? Who was the father of AC distribution system?
Nikola Tesla.
Nikola Tesla, right? So, yeah,
वही फर्स्ट नंबर निकोलस टेस्ला.
yeah. The second, the disadvantage of the geothermal based technology. What is the disadvantage? Okay, so geothermal technology, it makes use of the power present in Earth's crust, right? So in Earth crust, I'll just so let's say this is the Earth. So we have a core. So when we dig deep, arey yaar, okay. So when we dig deep, arey yaar, so when we dig deep, we can get thermal power out of our this, and we can use it just like any other thermal power plant to be able to run turbines. And this is what a geothermal based technology looks like. So why is it disadvantages? It's because of the fact that it's highly dangerous for the environment. So
Environmental effect.
yeah, why? Because you have to first vacate a large area, then dig, and then it can cause seismic activity as well, because you have to dig large holes as well. So this can cause a huge amount of environmental impact. So what is the function of a smart information subsystem? So this we discussed, if you know.
All of the above.
Yeah, all of the above. So our smart information subsystem, where was it? here, right? So you want everything, your generation to billing, your smart metering, sensors, analysis, integration, everything, it's done through smart information subsystem. So in fourth, in the service provider domain, which of the following is a part of account management? So in service provider, there is billing, customer billing, then you have account management and stuff like that. So what do you think would be a part of account management? And these questions are very theoretical, so but still I have to try and make you practice them. So what is the answer?
3.
Yeah, it's managing and managing the suppliers and customers' business accounts. Fifth, in the smart grid, the distribution system domain will communicate more closely with the operations domain in real time to manage what? So you have distribution domain.
Sector.
What?
Power flow.
Power flow,
Power
right?
flow.
Yeah, yeah, right. Power flow. Why? Because in distribution system now you have these distributed generations, right? So you want to be able to monitor how and when to have this bidirectional power flow in the system, and you have to be in close contact with the operations system. Next, which of the following standards represent the interconnection of distributed energy resources?
1547.
1547. The meter concentrator is responsible for just a second. The
What?
meter, yeah, with meters over what?
NAN.
Yeah, nan. RF mesh based
From of
huh?
full from of NAN.
Neighborhood area network.
Neighborhood area network.
Next, RF mesh is based on radio communication over unlicensed spectrum such as the frequency of. So I didn't talk to you about it in deep, but it's based on 900 I feel megahertz. Just let me check. So these are some standards which you just have to keep in the back of your mind. I mean, I am not really a fan of learning things in this way, but where did it go? Okay, somewhere it was. Hmm. Yeah, so the answer, yeah, here. So RF frequencies operate at 900 megahertz. So the answer is 900 megahertz. So what is the energy range of a commercial consumer in the customer domain? What do you think is the correct answer for this?
Second.
Yeah.
C.
Mm-hmm. Yeah, tell me.
C.
C, greater than 200 kilowatt. Commercial
No.
consumer.
Yeah.
3.
Okay. Okay.
It's because it's a commercial. What do you mean by commercial consumers?
Used by the people
Mm-hmm.
uh, in distribution system.
Mm-hmm. So commercial customers are those customers that use it for some kind of a commerce activity, right? Like for example, businesses, these things, right? So these will
Yes.
be in
Yes.
20 to 200 kilovolt only. You won't require more than that. Above that, it's industrial usage. Next question,
Yes.
grid
Yes.
assets are bought and sold in which domain?
Grid asset market domain.
Yes. So in market, suppliers and retailers come together to sell or trade grid assets, like for example they can be your energy, your ancillary services are services that are required to support the network and other stuff. So which is or are the boundaries of the customer domain?
Both of them.
Yes. So ESI is the primary service interface to which domain? Yeah, this is the,
Customer.
yeah, customer domain. Next, dash domain is responsible for the smooth operation of the power system.
Service provider. Maybe.
Think of it again. Why will provider be responsible for smooth operation of power system?
Power system. Then the
Distribution.
distribution.
Smooth operation, right? So operations domain.
No.
Operations domain takes care of what? I talked to you about in this, na? So this is your operations domain: control, monitoring, planning, security analysis. So his responsibility is to provide smooth operation of the power system. Next, the electrical distribution system may be arranged in which of the following configuration? So what is radial? Radial is connected one next to each other, right? So this is radial. You send power here, you can receive power at any node. This is radial. Looped, yeah. What do you want to say? Okay. So looped, just a second. Let's say that you have this system and you add one loop from here to here, right? So now this system becomes a looped system because
Loop.
now you have a bus over here which is in contact with two nodes at a time. Three nodes at a time. I mean this and this, right? But in radial only two nodes were in contact with each other. Next, so the distribution system can be arranged in any of these followings, right? So you can have meshed, not only radial loop, but it's generally meshed. Meshed is radial plus loop, that it has both radial plus loop. So this is in general a meshed system. So distribution systems are generally meshed. It's not like you are perfectly radial in nature, it's meshed. Next, which of the following regulatory authorities regulates tariff, formulates policies regarding subsidies and stuff like that?
Ministry of Power.
No. Anything?
Sir,
Sir, yes. What is the full
uh,
form?
the excuse me, sir.
Yeah,
For
yeah,
the
yeah.
previous question, if we mark all of the above, is it wrong?
See, that's a technical flaw. The answer is meshed, but if you go by this way, it can be all of the above, but the correct answer is meshed. The correct answer given to me by NPTEL was meshed. All of the above was not answer,
Oh,
but yeah, that can be a correct answer as well. There is this thing where sometimes the question does not make sense, but
Only not in radial and only not in looped, so it is missed.
yeah, only what?
It's not only in a radial and only in a looped, so it's
No, she's
missed.
saying she's saying can it be, so it can be radial, na? You can have radial distribution system as well. So it's like maybe arranged. So what whoever asked this question, I'll just say this to you that if there is one correct answer, pick that. Don't go for all of the above. Don't do that. I'm just
okay, so thank
telling
you.
you because you will be facing these questions in the next assignments as well. I have not made these assignments. Don't just be like, okay, why are you making these assignment? I haven't done that. Next, last, what is the major amount of where does the major amount of electric losses takes place? So this was discussed extensively. If you can think of where are I square R losses more prevalent?
Secondary transmission.
No, wrong. So I'll tell you why, but if someone knows the correct answer, can just tell me.
The major amount of electric
So
loss.
if you look for if you look for the circuit meter length of transmission system compared to the distribution system, your distribution systems are very large. And in your distribution system, because the voltage is less, to transmit the same amount of power that was coming from your generating station, you require you require a large amount of current, right? For the same amount of power, P is equals to VI. Now your V is less, but since your generating station is supplying some P, and your power needs to be balanced at all time. When V decreases, your I needs to increase. I'm sorry, generating station, I'm saying transmission system. So your I needs to increase. Now your I square R losses are proportional to the squared of your current, right? So in your primary and secondary distribution systems, your electric losses are very high. Always remember this. Any doubts?
No.
Great. We have another set of questions. These are very easy. These are multiple select. So you have to select multiple of these if I mean if there are any. So sensors can be used for the following purposes in the smart grid. Can you tell me which of these?
एक तो फर्स्ट होगा
Yes,
Real
you're correct.
elect- C.
Diagnose imminent as well as permanent faults. Yes. B नहीं होगा. Real time mechanical and electrical
Time
conditions.
mechanical.
अभी 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 मयूर जी ने बोला कि आईईडीज डिजिटली ट्रांसमिट करती हैं वेदर स्विचेस आर क्लोज्ड और नॉट. सो मैकेनिकल एंड इलेक्ट्रिकल कंडीशन स्विचेस से नहीं आ सकती, सेंसर्स वहाँ पे नहीं लगाए जा सकते, आईईडीज लगती हैं.
लग सकती है.
हाँ, तो बी इज ऑल्सो करेक्ट आंसर. ए बी सी. Next, what are the main challenges that the electric grid faces? This was also discussed.
A also increasing energy demand.
Yes.
Get customer. C is not. C तो नहीं होगा.
C तो नहीं है.
ग्लोबल राइज इन टेम्परेचर, उससे क्या मतलब है?
हम्म
हाँ वो है ग्रीन कार्बन एमिशन.
हम्म
डी.
और E.
ई. ई. रिलायबिलिटी एंड पावर क्वालिटी आर
क्यों?
डिक्लाइन.
Because of renewables.
राइज ऑफ द मिडिल क्लास, ये कौन सा ऑप्शन हुआ? ये भी होगा.
ये भी होगा. राइज ऑफ द मिडिल क्लास इसलिए देखो, पहले
इसको बार बार लाते
पहले
हैं.
मैं बताता हूँ, पहले कार्स वर अ लग्जरी, राइट? कार्स वर अ लग्जरी. पर लोग धीरे धीरे अब हर किसी के घर में कार होती है. पहले
ये
AC was a luxury. Now everyone at their homes have AC. पहले
इसी.
washing machine was a luxury. So that means rise of the middle class means that your middle class is more empowered to spend money at those things that were considered luxurious at one point
Not
of time.
rise of EMI.
हाँ.
rise of middle class, not rise of EMI. EMI पे सब ले लेते हैं.
भाई खर्च पा रहे हैं तभी तो EMI पे ले रहे हैं. चलो ठीक है. I mean that is
Maybe
different.
it could be better, increase in the per capita energy consumption.
Yeah, I mean, I haven't. These are not my questions. If I would have made him, I would have.
That
I
is
would have
not
kept
the,
it different.
yeah, okay.
Yeah, these are not my questions. So, third question: a system that, again, I mean, at the face value, this looks very wrong, but I have to discuss what I have to discuss. Third, a system that integrates several types of power sources to give a reliable overall power supply is termed as. This I did not discuss, but yeah.
One microgrid.
Okay.
Virtual power plant होता है. Micro traditional.
But does it give overall power supply? Can it supply to other grids as well? Why would it do that? Microgrid serves the purpose of being standalone when the grid connection is off. Islanding is called. It's called islanding of microgrids, right?
Island.
So the correct answer is virtual power plant. I'll tell you I'll distinguish all of them. Just bear with me for a second. So traditional grid, it's not the correct answer. So a virtual power plant, what it does is it has different kinds of systems to generate electricity. Like for example, it can have wind turbines, hydro, photovoltaics, and batteries. All of them together in a system, right? Working with each other to provide reliable power supply at any given point of time. Why do they call it virtual power plant? Is because they act like a power plant, but they are virtual in nature. They were composed of different set of units, and they can supply any demand, not any, but some demand of power too. So virtual power plants are growing, and they now are also coming into picture in USA, where they are now integrated into the RTOs, where they supply power in the sorry, where they take part in markets as well. Microgrids are designed to be used as standalone systems when the connection to the main grid is off. Macro grid is nothing but your grid only, the traditional grid which houses everything, your transmission system and everything. That is macro grid, I mean, bigger picture, right? So the correct answer is virtual power plant. Always remember, a virtual power plant is the one that can provide supply of power. Mini grid does not do that. Sorry, microgrid. Fourth question: a localized grouping of electricity generations, energy storage, and loads is termed as. Now answer this question.
Microgrid.
Yes. Why is that? It's because these can support using this electricity generation devices like photovoltaics or energy storage. They can support loads for the time they are disconnected from the grid, right? Like for example, a hospital, it can act as a microgrid. Next, communication dimensions for smart grid. So what do the person who made this question wants to ask is what kind
Micro
what kind of things you want your communication systems to be in order for it to be a safe dimension for micro smart grid. It should be reliable. Should it be
Yes,
reliable? If my
yes.
communication system is
Stability,
not reliable, my smart grid is it's not smart, right? Should it be stable?
stability is
yes.
also there.
Yes. What is understandability? I don't know. Understandability, I don't understand what is understandability. The
Easy
User
and
friendly.
available. Yeah.
nay, understandability is not user friendly. It should be measured. Yes, measurability is perfect. Like for example, whatever communication or your measurements that you are getting, that should be they should convey something, right? So measurability is there, availability should be
If
there, and you should
flexibility.
it should be flexible
Flexible.
as well, right? So A, B, D, E, F. Clarity. Should clarity? I don't think clarity. What is clarity? Yeah, go ahead. Someone was saying. Okay. Sixth question. Select three wireless technologies. I think clarity should also be an answer because if let's say your communication systems have too much disturbances or distortions, they are not clear signals, so your smart grid will suffer, right? That I don't know. Sixth question. Select three wireless technologies from the list below. What are wireless technologies in these?
Cellular,
Hmm.
Satellite,
Sat
fiber optic.
and C number.
and radio, right?
C number.
Hmm.
Radio.
How to manage demand on a smart grid network? Who can answer this? It's very. Come on, tell me.
B. Use excessive energy.
Reducing consumption.
Shifting of demand to another time of the day.
Yeah, shifting demand to another time of the day. That's correct. Anything else?
B.
Reducing
Reschedule.
consumption.
Why would B be an answer? Do you want to use more and more energy? That's what smart grids are being used for. You want to use more and more energy. There's this term excessive energy. Why do you want to use excessive energy? You don't want to use excessive energy. You just only want to use that amount of energy which could sustain the load. Rescheduling usage. C was correct. Whoever answered. Anything else? Can anyone answer this? Can reducing consumption help? We talked about all of
Yes,
these
we
things,
can.
right? User feedback. Yeah, right. So reducing consumption is also there. Now last eighth. This I only talked because this was there in the question. So now I told you what its role is for the grid. Can anyone tell me?
Frequency regulator for the grid.
Yes, they act as frequency regulators for the grid. I don't know why they have this question, but because they had this question, I touched why pumped hydro storage would be there. I don't know. Okay, so so today we just started this smart grid. So we just covered, this is week one. We just covered what smart grids are, why is the need, what is the need, and I got some very interesting questions to answer from Mayur, and I'll definitely look forward to. And we talked about. We started with what conventional electrical grid is. We talked about AC versus DC transmissions, the skin effect, proximity effect. Then we moved on to the Indian system. How does the Indian system look like? Where are we in terms of generation, usage, renewable energy generations, and stuff like that? Then we came on to why we need smart grid. Due to the fact that we have a very wide geographical spread, we have large number of interconnections, we have rapid growth in demand, and we want to facilitate that. And we have so many power system components, and we have now the one big concern, which is the integration of renewable energy, which is highly variable and intermittent. Right, then I don't know why we digressed to RPOs, but we did. Then we discussed what is smart grid, the domains of smart grids, the differences, and the advancements that they are currently undergoing. We discussed about the use of smart meters in monitoring, how PMUs come into play, which Mayur is not convinced. We discussed communication, we discussed smart grid standards and the domains that it does. And we moved on to the last two discussions were on AMI and distribution system automation. And then we discussed questions. So I hope you all got to learn something, some valuable thing from this, if not everything. And if there are any doubts that you want to ask, you can do this. It's already 2.3 2.5 hours since this class has been running. So yeah, if anyone has any questions. Such a long class. You stayed with me for such a long class. That's wonderful. I would love to see you next week as well. I mean, it shouldn't be like it's week one and then you all come and then you vanish. Last time there were only 3 students that stayed till the end, and I was like very happy. So, any questions?
Sir, we'll get your PPT.
You'll
What
get
you
my
have shared.
PPT and you'll get my YouTube this video as well. It's being recorded as of now. Anything else? If that's all, we'll end this meeting. So I hope you enjoyed this lecture, and I hope to see you all next Tuesday as well. And I hope you would solve your assignments too. So that's a very integral part of your marking, right? So thank you. Have a wonderful day ahead. Have a wonderful evening. Bye.
Thank you so much.
Bye. Bye.
Thank you, sir. Thank you.
How to contact with you? So you can have
Thank you.
my email ID. I'm adding my email ID here. You can always email me. I'll be happy to answer you over email. So just quickly take a screenshot so that I can end this meeting for everyone. Done. Thank you. Bye bye.